All right, welcome back. We getting rizzy with Triggy. So, right? Right? I can feel it. I'm in the wrong section, so that doesn't even make sense. You said 34? All right. So in this video, we're just going to work a couple examples, one or two, like legitimately, and then if we need more, I will resume the video, and there's a possibility that we start the next piece as well. So for an example, we are graphing by hand. I'm fine with that. And one of the questions from the homework was number 34. So I'm going to look at 34, and you're asked to graph two functions on a single plane. So looking at that, you guys have your books open. I'm impartial to this. Do you want me to do 33 or 35 as the example? We're doing this based on the question about 34. I lied. Let's do 35. Did you guys have to do 35? Let's do 35. So this is number 35. We're sketching these two graphs together, and we're asked to include two full periods. So here are our lovely functions, and I'll do different colors for both of them. First of them, we have this lovely function called f of x, and whether it's f of x or theta doesn't matter. I'm going to use x since that's what they did. We have negative 1/2 sine of x halves. Okay? And then in this lovely blue color, we have another function that we will call g of x. And this thing is also awesome. Well, that's not fun, but that's okay. 3 minus 1/2 sine of x halves. 3 minus 1/2 times the sine of x halves. All right. Full honesty here. Thumbs up says, yep, I got this. I could do it. Thumbs down says, ah, or some variation of that. Okay. This looks kind of scary. Makes sense. It's not. We're going to go through the time. On one of these, I'm going to talk out, and the other one, I'm going to make you guys do the same stuff with it. So, which one looks scarier? Blue or red? Blue. Okay, so I'll do red. I'm good with that. Sweet. Here we go. For this, I don't normally write this down, but I will this time. What is A on this one? The amplitude. So, weird little language thing here. I'm going to claim it's 1/2. Now, we'll talk about why I'm doing this, because you're right that I would call it negative 1/2, but the negative doesn't change how big it is. The negative changes something else with graphs. Here's x squared. What's negative x squared? It's reflected, right? So I'm just going to make a little comment that this thing reflects. Or it has been reflected. Now, whether you actually jot that down or not, up to you, but especially while we're doing these first kind of ugly ones, maybe it's worth it. Okay, what's b? Bx is the variable, or the number connected to my variable. 1/2. X over 2 is the same thing as 1/2 x. This is just a more convenient way to write it. That is going to happen over and over. B is 1/2. Cool with that? Okay. What did you whisper? Or was it not about this? Secrets don't make friends. Friends make secrets is the appropriate answer for future reference. C. What? Secrets don't make friends. Like, that's true, right? Like, if you're telling secrets with somebody, you're not going to make friends that way. But the appropriate response is friends make secrets. And Sean is right. 0. Because it's bx minus c, I'm not subtracting anything. It's 0. Is there a delta on this one? Okay. So how do I write there's no delta? 0. Cool. All right. Decision time. Do you guys want a second to identify all the same pieces on this blue one, or do you want to finish up? We'll graph this one, and then you'll do the whole process with your blue. Executive choice. Let's finish your red one, and then you guys will do the blue part. Cool. All right. So as I'm trying to work this out, honestly, I don't really care about the amplitude. The fact that it's been reflected will play a role for me, but that'll come up here in a second. I really only need like 2 things to deal with. First thing that I need is for this red function, I need the period of it. And I know that for any sine or cosine, I take 2 pi and I divide it by what? By b. So this is going to be ugly for a second, but it's 2 pi divided by 1/2. Hate it. But it's okay because we can do the whoa. Or multiply by the reciprocal more appropriately. What does this come out to be? So I heard the answer, and you're right. But if you're struggling with this, instead of dividing by a fraction, what do we multiply by? The reciprocal. So this is 2 over 1. And I think that we just determined that the period was 4 pi. Okay. This function, because there's no c, am I going to have any shift left or right? No, we're not. But I'm still going to model this process for you. Whether you recognize that or not, maybe. But I do want to make sure that we find the start by. Now, yesterday we did this big inequality and compound inequality. I'm going to say let's start at an x value and we'll find it. Yesterday I think we added c and then divided by b, right? So let's do that. It's c over b, whatever that winds up equaling in the end. What is c? So this one's going to feel like at this point, do I really need to write anything else? Because no matter what I put in the denominator, as long as it's not 0, it's still 0, right? 0 divided by anything. However, if I wanted to show it, what would it divide by? 1/2. And just like I had predicted, it's still 0. Okay. I don't care about the end because it's naturally going to show up. I know it's going to show up. I know I'm going to start at 0. The only thing that needs to change is we take the period that we just found, 4 pi, right here, and we cut it or divide it by what? 4. So I'm going to say the jump is just the period we found, 4 pi, and divided by 4, which means the jump is going to be what? Pi. All right, I'm going to give you guys a second. I want you to make a table. I was going to yell at Ula, I think it's whose voice it was, but I wasn't sure. Yeah, there were other people walking the other way too. Okay. I'll do it here. I'm going to make 3 column for now. Whether your table is completely filled in or not, I at least want you to be able to, right now, get all the x values that we're going to plug in. Okay, left side, I'm going to start running out of space here. 0 is our first one, because that's where I started. Then every time I add a new value, I just jump by how much? So the first one is pi. What's the next one? 2 pi. The next one? I'm not going to jump by 2 pi this time. 3 pi. So 1, 2, 3, 4, and the last one? 4 pi. Now, there are some shortcuts that you can work out as long as you know that sine normally does, it starts at 0, right? And then sine normally does this. Okay, that's what it normally does. What happened with this, though, according to that a value? Instead of doing this, instead of going up first, what's it going to do? It should go down and do this instead. It's just been flipped completely upside down. Now, there are a ton of shortcuts, but as soon as I get the first 2, I think the pattern becomes clear if you're not comfortable trying to take a shortcut. When I plug in 0, what does it make my argument? So I'm going to say, and you weren't here, Sean, don't call it sin. Yep, sine. And let's check this out. What's the sine of 0? Here I am at 0 radians. What's my y value? 0. So now it's negative 1/2 times 0. It's 0. Now, the shortcut stuff that I'm talking about, you don't have to sketch this one. I know that sine normally looks like this. If I flipped it, it would then look like this. Do you guys agree? So normally it starts at 0 and then goes up to 1. This thing has been reflected, though, and its amplitude is cut in half. Instead of going to negative 1, what do you think it's going to go to if it only goes half as far? Okay, I'm losing you guys on that. Let's do the second one real quick. When I plug in pi, what does it make my argument? So I agree with you. Do you know what I'm referring to with the argument, Sean? Just to check. Because you've answered what does it make the function, which you're absolutely correct. This is just the argument anytime I'm asking. But you're good, like you're correct. Okay, I have negative 1/2 times the sine of pi halves, right? So check it out. Here I am at 0. Pi halves. What's the y value up here? It's normally 1, right? So now it's negative 1/2 times 1, because we just worked out that sine value. And I think it's negative 1/2. And again, I'm just running out of space because I want to be able to this to show on the notes. Here's what I was trying to get at a second ago. Normally, my sine function, the solid one here, and I'll erase it so we can make it a little bit more clear. I'll erase that part. Normally, it goes all the way up to 1, right? I'm going to go yell at them real quick. Hey, you guys are aware that I teach class? All right. That might be the most angry you've ever seen me. That really bugged me. All right. So check it out. I know normally it goes up to 1 because the normal parent function has an amplitude of 1. Everybody cool with that? Okay. Now, this part is just me thinking, and I'm trying to show you some shortcuts that'll work. If I just flipped it and didn't change the amplitude, instead of going up to 1, it would go down to what? Everybody agree that it now would go down to negative 1. However, it's not the same amplitude. It's only half as far, right? So instead of going all the way down to negative 1, where do you think it's going to go? And so all the way down to negative 1/2, and then it's going to go all the way up to positive 1/2 as well, right? So check it. As soon as I recognize that that's what's happened here, I get the rest for free. It went from 0 down to negative 1/2, up to where again? Then up to where? One more time. 1/2. And then finally, the last little fifth point that we've chosen, back to 0. If you know what the parent function looks like, and you really truly understand this amplitude and the reflection, there's shortcuts everywhere. If somebody's looking at this going, Holloway, there's not a chance I'm ever going to see this shortcut, does that mean you're just not going to be able to graph these? Absolutely not. All you have to do is 3 more values that they're going to spit out nicely because of the way that we've picked them. It's okay if you have to take the 5 values. You probably are not going to be able to graph sine and cosine functions in your head right now. That's okay. All right. I want you guys, I'm going to pause the video. I'm going to give you a head start because I left a soda in the freezer again. We will graph this like really specifically here in just a minute. This is just my rough thought idea. I want you to do the same thing on this one. Cool. I'll be right back. So I identified the start, and we might have already talked about this. I'm kind of having trouble remembering right now. But as soon as I get my start and my jump, I do all 5 rows of the table. Now in hindsight, maybe I should do the first row and then write the second one space accordingly so that I have room to show my work if I have to. But that depends on you. I would strongly encourage, actually include this. What is the sine of 0? 0. So I have 3 minus 1/2 times 0. So if I just simplify here, what's 1/2 times 0? And that means my first value is at 3. Take this time. Unit circle in front of you will be helpful. Now, there's a few things that I know. This is the middle of my function because sine starts and it either waves up like this or it waves down like this. But in either case, this is the middle, that first point that we pick. Now, it happens to be at 3 this time. But check this out. Normal sine goes up its amplitude to our next point. So normal sine goes up 1. This has been flipped, right? Because it's minus. So if this were just minus, it would go down 1 instead. But what's its amplitude? So instead of going down 1 full unit, it goes down 1/2 of a unit. So a couple ways we can think about this. I really don't care if you want to use decimals. I'm good with it. In my head, it's easier right now. 2.5. Or we could call it 5/2 if you would rather. Okay. So notice, again, we started here. We went down 1/2. What's sine going to do next? It goes back up to its balance point, which was at which y value? 3. And then it does what? It goes up another amplitude until it's where? And then finally, one more amplitude back to where we started. We're at 3. Is the time saving worthwhile, do you think? I think so, big time. Is it, again, I just want to stress, if you don't understand the shortcuts and you keep getting stuff wrong, is it required? No. We've picked values that if you wanted to plug all these in, this becomes 3 minus 1/2 the sine of pi halves, which turns out to be 3 minus 1/2. This is 3 minus 1/2 times the sine of pi, which is, again, just 3 minus 0. And we can do this whole table. Your knowledge of the unit circle will make this go faster. Your recognition of these patterns will make this go even faster still. Okay, we now have 2 tables, and they're very different sizes and such. There they are. Can we graph those 2 on the same plane? Do you need, and I guess need isn't the right word. What planet is that? I don't think it's Jupiter. I think it's Pluto. Cool. So I'm just going to copy and paste this onto another page so we can see it. The graphing part, in my mind, is the easiest part, but I don't know if you guys agree with that or not. Getting the table is challenging, but the graphing itself, is that where you struggle? Okay, well, let's graph this then. Okay, so remember, we get to pick and choose, and we get to make this work for us. So here we are. I'm going to graph this. I'm going to graph both of them on the same plane. So I need 2 full periods. I know that much. You have 2 options. If I know my first period goes out to 4 pi, could I do the period on the left of it that goes out to negative 4 pi? I could do it like this so I can see 1 positive, 1 negative. It is equally valid if you just do both in the positive direction. I don't care which one you choose. In my mind, it's more natural to do 1 on either side. So I know I go out how far? From 0 to 4 pi, right? So check it out. I'm not picking a scale, like I'm not looking at grids or anything. Is it possible that that's 4 pi? Which means this right here would be what? 2 pi. And I don't have room to label them, but I'm going to put the hash marks for pi and 3 pi. I'm always going to pick right off the bat my period, and I'm just going to cut it in half until I get my nice points. Okay, eyeballing it out, I go the other direction. Here's negative 2 pi. And there's negative 4 pi. Is it perfect? Well, that hurts my feelings. It's okay. All right, now looking at this, I don't care if you erase it or not. I see this first one goes from 0 to 1/2, so I should probably be able to see 1/2. The second one goes all the way up to 3.5, right? So let's pick a scale here. If I do 1, 2, 3, and 4, and I do little half marks in between, I can get my nice fractions. I don't need anything negative. Now, I included quadrants 3 and 4. Didn't really need them. Cool. I'm going to make sure it's really clear. There's a 1 and a 2 and a 3 and a 4. Once we've picked out the scale, these things are just always going to look the same. Whether it's been really shrunk down, like compressed horizontally, the period has been made tiny, doesn't matter. When I draw my graph, it's going to look like just a regular old sine wave. Okay, so let's check it out. I'm going to do red first. So I get 0, 0, love it. Then I get pi 1/2. Then as soon as I start this, I can see like immediately where everything goes. I did something wrong. What did I just do mistakenly? Gosh, I just was so excited to graph sine that I graphed positive sine. But this is negative sine. You think that might happen from time to time? For sure, because I'm not trusting my points. I was trusting what I know about them. So check it out. There's my negative 1/2, and I'm going to try to make it kind of to scale. Negative 1/2, 0, positive 1/2. What am I doing wrong again? I'm trying to fill in the gaps between, and now I think I have it sorted out. Currently, when I draw this first one, I have a single period of this. If I want another period over here, I just got to continue the wave. I know it comes up, down. I just mirror it over to the other side. I now have 2 full periods. Okay, for the blue one, entirely up to you. I'm going to use this obnoxious yellow just to help me. I don't physically draw these normally, but that's my new 0. My horizontal line, because this thing has been shifted up 3 units. Cool. I can graph this one in blue, no problem. I know it starts at 0, 0. This one's also negative, right? That's not blue, though. Okay, so here we are. I start at 3, and then I go down to 2.5, and then up, and back down. I missed a point, and it's going to bug me, so I'm going to fix it. Does that look like the same function, just moved up 3 units? Piece of cake. Now, if we want another period, which it does ask for it, I'm not going to put a ton of thought into it, but something like that. Now we have 2 full periods. These things are easy to graph once you get a little bit of practice with it. Cool. Does this feel better now than it did yesterday? Is it possible that... Nope, not even going to bother with it yet. Cool. I'm going to give us time to work. Baller. We have a lot of time left in class. Get to it. I'm here with answers to questions that you might have. As we get finished, we may be able to start stuff for tomorrow or for our next section. We'll see. Cool.